basically other things, other numbers, so that when we upload this code to the Arduino board, we are able to get an output, and the LED lights could light up at different occasions. You just copy and paste. Change the numbers to number 6, number 5, according to what we declared. Sorry about that. This is number 5. So we're done here. Let us go to our loop. A loop is something that runs repeatedly. So we basically want this to go on and on, like a robot, But this time we're using LEDs that are blinking at a certain extent. So we'll write our digital write. Instead of using console.writeLine, here we use digital write.
Lishle?
Yes?
Sorry.
Okay.
Yes.
We can't see your Visual Studio.
Okay.
Lishle?
Yes, I'm sharing again. Sorry about that. I thought you guys were seeing it. Can you see it now?
Yes.
Yeah,
Okay.
yeah, we can see it now.
So this is what I've been explaining. Here on the voice setup, on the top, the ends LED lights. I was declaring my LED lights and the numbers that correspond with the numbers on the Arduino board, and the ones that are connected to the components on the motherboard. So I was declaring here, and this is my pin mode, the outputs on what I want it to output on. And here on the loop, what I'm basically writing is a code so that this could happen repeatedly, so they can light up at a certain time repeatedly. So I'll basically call on first, let's do page number 7. Because 7 and 13 work correspondingly, I'll start with them. 7, and always make sure here too that your high is a capital letter and every letter on high is capital letter, because this is case sensitive. And then again for digital rights, we also do the same for number 13 because they work correspondingly. So we want them to light up at the same time correspondingly. That is why I write them at the same time, and then I'll write a delay time. A delay time is basically like you're saying that after 1 second or 2 seconds, the next roll shall come. You can write any seconds you want, but on my program, on my Arduino, I just want 1 second, so everything can be like faster. But you can delay it any second you like. So this is basically, it will light up, 7 and 13 will light up at the same time with a delay of 1 second. And then let's just copy this and paste this to make this faster. And we don't, if you want, it's up to you. You can do your own project, your Arduino project. It's up to you if you want all the lights to light up at the same time, or just all the lights to just light up and not. And for them not to light up, if you want them to just continuously light up, that's your option. It's your project. You can do it anyhow. If you want to add a buzzer, because there are options where you add a buzzer. If you want to add something else, it's your project. You do it anyhow. But I'm just doing like a simple Arduino project for those who haven't done any Arduino projects, or for those who don't understand on how an Arduino project works like. So I'll do the same with the other components, being the red lights and the blue lights. We'll make them high at the same time. For instance, the red lights being the 6 and the 12, but let it light up at the same time because I want it to be like a blinking LED, similar to a robot. And this is low. This is low. And this is also low. And this is for 5. And this is for the blue lights. The reason why I said that I'll be doing a delay that is 1 second, because I want it to be faster and I want everything to go according to plan. So that is why I used 1 second. You can use any second you want, it's up to you, basically. To 6, to 12. So you want it to go on and off. That is why I'm writing these highs and lows. Let's cut this because this is extra. So I just cut it. So this is basically how the code basically looks like. A simple code of a blinking LED light. And we can check here and verify if everything is correct. We put the right things in the right place. Here it's compiling our sketch. Okay, it did something wrong here. Oh, we forgot a semicolon. And that is crucial for most coders. When you forget a semicolon, it may happen that your code might crash. Oh yeah, I forgot to remove the high and put low. We'll check again if there are any errors. It's compiling our sketch. Digital right. Oh, sorry, I misspelled digital. My gosh. I'm sorry about that. I misspelled digital. Just correct it. But always make sure that you check before you upload, because you'll find that once you upload your program, it's not working, but it was just minor errors that you didn't check. Yeah, let's check again if there are any problems. Compiling our sketch. Oh, this one. Just wait a few seconds while it's compiling and checking. You see, it's written dynamic compiling. When it says this, it means that your code doesn't have errors anymore. Your code is fine. You can now upload your code. Once you have done fitting your components on the Arduino, you can upload this code and everything will work properly. You just press this button and upload, and it will automatically upload to your program. And if you had inserted the right components at the right places, then you are able to get this right. Without wasting your time, let me just stop here for today. Nosipho can carry on the videos. Thank you, guys.
Oh my God. Hello.
Yes.
Hi, Nosipho.
Can you hear me?
Yes,
Yes,
we
we
can hear
can.
you.
But anyways, I'll just take you guys to the videos of of how we can use the Arduino board, and I'll just share my. This is a short thing I'll do. I don't have much to say, really. Share screen.
While Nosipho is still trying to connect, I think I saw Spume, you have a question. You can ask your question in the meantime.
Hey guys, I don't know if you can hear me, but I had a question about indentation. Like, does people are using? No, I don't know. I don't know how to pronounce that. But like, does indentation matter when you're using it?
Sorry, can you repeat the question? I didn't hear you clearly.
Okay. I'm asking if indentation does matter when you're using that IDE or editor. Yes.
Perhaps Pume, not in a bad way, in fair to can you simplify what's an indentation?
Okay. If I can put it, it's like the space before your sentence, like and straight. No, not that straight. Halfway. But like the indentation was different. So I'm asking if it doesn't matter if the spaces are not the same. The length of the spaces is not the same.
Which spaces?
Can you please show your thing, your code again? I think it will be easier to
Okay,
pick
let me
out when
show
I
it to
see it.
you again. Okay. Just give me like 2 minutes. Can you see my screen? Spume, can you see my screen?
Oh yes, I can see it now. So like you see, like there's this line where digital rights is not along with the other lines. Like it is more pushed inside than the other lines. So like that's what I meant by indentation. Like it is not the same. Does it matter? It's not the same.
No, it doesn't matter. No, as long as see, as long as you write the correct word, like you write it and spell it rightly, it doesn't matter. See, people, and as long as it's inside the colons.
Okay. Thank you.
Nosipho, are you still there?
Abongile has a question. You can ask your question. I see your hand up.
Hi. I wanted to ask, what were the websites that you used to actually like search for your project? Because I would like to do some as well.
You can search for Arduino projects. What's it called? MySpace. It's along those lines. I'll get back to you, but it's MySpace, I think.
Thank you.
While waiting for Nosipho, is there any other person who's got a question?
Yeah, I have a question. Hello.
Hello, Letu. Hello.
Oh, okay. I thought you guys couldn't hear me. It's a question for
And
Lishe. I want to ask, what kind of projects can you make with Arduinos? I know that it's part of like IoT, but what are the projects that we can use on campus to upscale the learning using Arduino kits?
Okay, the ones that I know of are your fingerprint lock door opener. That's one you can use on campus. If like for instance the one that your guys use on races, and those ones are also, you can make them using Arduino Arduino boards, and some I'm not really sure of. But you can also like do like For instance, there are some like your track stimulator. Maybe you can like use a voice stimulator or a voice projection project. You know, it could work with Arduinos.
Okay, thank you.
Hi guys, can you hear me?
Yes, sir.
I was still waiting for Nosipho to come in, or
Yeah, we're still waiting for Nosipho, but you can ask your questions if you have.
oh, okay. Speaking of Arduinos, right? This is dedicated to Lishle, right? For anyone who wants to like try out working with these technologies, do you need any prior knowledge, or like what is sorry about that. Yeah, is there any prior knowledge you need to understand how Arduinos work and to get started with implementing them on your solutions?
I
I don't
think
know if
if,
that was
if you know
audible.
like, okay, if you know like basic code, like even if you don't know like deep code, you can learn C++ with just on that particular day. It's not rocket science. You know, you can start developing like a simple project, and then working on learning on other projects online. Maybe you gain more information. I don't think you have to know uh, like tough code prior, because the time I started learning this, I didn't know much about C++. It was actually my first time working on such a thing. And you know, as time you learn and you adjust, like for instance, if you know what an Arduino is and how it works, and you learn along the way, you know, it's not something that you should like crack yourself on. No, it's not too hard, it's not too simple, it's just okay.
Oh, all right. Thank you, Lisa. One more question. How does Arduinos differ from Raspberry Pis?
Okay, I didn't expect that question, but anyways, how do I explain this?
Oh wait, you didn't get my question.
Yeah, can you repeat it?
Okay. I was asking, how does Arduinos differ from Raspberry Pis?
Oh, okay. Uh,
Hello? Am
Hi.
I experiencing network problems?
I think it's Lishe, because I
No,
think she's
Oh,
I think it's Lisa.
oh,
oh
Yeah.
no, sorry. Sorry. For my understanding, you know, they are not the similarities I can do. They are not the same in the implementation. And how do I say this? My Raspberry Pis are used on low cost credit size computer plugins into monitors and televisions. And they don't use the same language, because some Raspberry Pis use Python, while some Arduinos use C++. So that is my one knowledge of differentiation between the two. And I believe that they are not, how do I say this? They don't work the same thoroughly, but they are similar because you can plug in, you can like and automatically put it on the Raspberry Pi on the Arduino. I hope you get my answer to your question, and I hope I'm able to answer your question properly.
Awesome.
Thank you, Lisha. Thank you. Thank you.
Awesome. I think a question from me would be, let's say I'm interested in IoT and I want to really start using, your Arduinos. What programming languages should I acquaint myself with?
For Arduinos, you have to know C++, and for my Raspberry Pi is Python. So if you want to go simple, you can start by doing Arduinos, just the basic projects, the small projects. And then along the way, you learn on how to input other components, being it your buzzer, your switch, and whatsoever.
Awesome. Thank you for answering my question.
I also have another question. Lishe, I saw that you created one project. I didn't really catch the name of the project and what it actually does. Can you please repeat on that point? And how many projects have you actually done? Were they beneficial towards your campus work or whatever work that you were doing it for? Or was it just for fun?
Okay, the project that I was doing was blinking LED lights. I said my blinking LED lights are similar to like a robot. I did it in that sequence. I want 2 parallel LED lights to blink at the same time, but with different time schedules. And to answer your question, the first time I did the project was familiarizing myself with my Arduino projects. It was beneficial of me, and I'm still working on another project that I want to do. Maybe that'll be like more beneficial than what I just did. That'll be like more complex, and maybe other people can use the project because this one is just a simple one that any kid can do.
Oh, okay. So can you talk about those projects or is it confidential?
No, it's not confidential. It's not confidential. So I was planning on doing like using these blinking LED lights, but at the same time add sound. So if the first row lights up, or maybe if a person touches one of my components on the model, a sound could light up. It's like a sense stimu project kind of. It goes about with different actions. If a person whistles, a bell could ring or a buzzer could buzz. I just want to interact like different components that could make the projects be like more complex.
Awesome. I think a question from me again would be, what interested you into like, I know you're studying application development, if I'm not mistaken. So what interested you into, learning about Arduinos and blinking lights and IoT?
Okay, the first time I was interested in this is when I saw all the IoT people. Well, firstly, it was them always leaving the lecture early, them going to places, and I was like, what are these guys doing actually? And then I got to see their projects, their different projects. There was, I think it was Priyanka's projects when she did a musical instruments, where it was like a piano that you can play different notes. And then I was interested in like, why can't I do my own projects? Something that could like be more fun or something that you can play with. And then again, that time I went to the organizer of this IoT at school, and then I joined, and that's where I started this IoT thing.
I have a question. So let's say I would like to deploy a project to production, and I would like to not use a breadboard. Is there an alternative that I can use, or do I have to use a breadboard?
There are projects that don't need a breadboard. You can do a project without a breadboard, but it depends on the type of projects you're doing, because some projects they need for you to display the components on a breadboard and then connect it to the Arduino, and sometimes maybe the amount of electricity from the computer to your breadboard needs like resistors to cool down the pressure, that's what I know.
Oh, okay. Thank you. That was very helpful. Thank you very much.
So a question from me. So I see that you did the project. I don't know if we're gonna get a GitHub link where we can refer to it while we sort of like imitate what you were building today. However, how can one extend like this project further?
Like to make it bigger or add other components or
Yeah.
okay, it depends on what you're adding and how you want that component that you're adding to work. Like for instance, if you're adding a buzzer, you have obviously you have to declare your buzzer, or you have to like tell us what is this buzzer for? Like it should buzz when a person maybe when the light goes on, the buzzer also goes on. So it's up to you basically on how you add on or subtract or anything like that.
Awesome. Perhaps what I don't know if I'm repeating a question that was asked. Um Okay, yeah, I think they asked this question. Perhaps if I want to see, maybe I'm lazy. I always feel like IoT is like for lazy people. Maybe I'm lazy to switch off my light, and I want to control them, from my phone. Perhaps what would you say I should begin with?
I won't lie to you, I haven't yet connected the Arduino to the phone. But hopefully it works, because to connect your Arduino to your computer, you use a USB cable. So if the USB cable fits your phone, maybe it's possible. I don't really know.
Awesome. Thanks for trying to answer my question. Is there anybody else who has a question? It seems like Nosipho is having technical issues and she won't be able. I'm sorry about the background noise. It seems like Nosipho won't be able to join, like to actually say something or even present because of technical issues. However, I think she would have liked us to watch a certain video showing what Lihle was currently doing. So I'm just gonna ask the team behind to actually try to, play that video and we can wrap it up. Tori, can you play it on your side? Spelele, Tori. Semeleza, can you try to play it on your side? Someleze.
Hey guys, I don't know if I'm having network problems.
I can't hear you, Leto.
There is one that I'm trying to show. Can you guys see my screen?
Hello?
Oh, I said it's sharing.
I'm not seeing anything from my side. Is anybody seeing something from their side?
I can try sharing.
Okay, cool. Thanks, Rob.
Just let me know if you can't see anything.
Okay, it seems like Lihle is sharing. Thanks, Rob.
There we go.
Awesome.
Oh, can you see my screen?
Yes, ma'am. No sound from my side. I'm not sure. Lihle?
Sorry about that.
Repeat this process for all three LEDs. Now it's time to complete the circuit. We're going to use output ports 13, 12, and 11 for the output signal. Connect the positive lead of the LED on the right to pin 13, the LED in the center to 12, and the LED on the left to pin 11. The circuit is now complete. Power on the Arduino board by connecting it to your computer using the USB cable. The LEDs on the board turn on and the board powers up. Before we work on our sketch, make sure to download the Arduino IDE for your specific operating system. I'll leave a link to where you can download the software in the description below. Once you've downloaded and installed the Arduino IDE, go ahead and download the sketch to run this program using the link I've put in the description. Open the downloaded file. The program first creates three variables, LED1, LED2, and LED 3. This allows us to change the output pins without having to modify the entire program. The code in the setup part of the program tells the Arduino that pins 13, 12, and 11 will be outputs. The loop portion of the program is where the actual instructions live. The first 3 digital write functions turn on one LED at a time with a 200 millisecond delay between each of them turning on. The next 3 digital write functions turn off the LEDs with a 300 millisecond delay between each LED. Now you can change the delay between each LED to change the rhythm of the LEDs turning on and off. Now you're ready to upload the program to the board. Click on the Tools tab of the Arduino window. Make sure the Arduino Uno is selected as your board, and make sure you select the COM port your board is connected to. Most of the times there will be one COM port available, and that will be the one you need to select. Click on the Upload button on the top left-hand corner of the screen to upload the program to the Uno. A green progress bar on the lower right-hand corner will indicate upload progress. And unless any errors appear in the black message bar at the bottom of the screen, your board should now be running the program and the LEDs should be turning on and off like you can see here. Hope this tutorial was useful. Please hit like for more Arduino tutorials and subscribe to stay tuned. Thanks for watching.
Okay, that is it.
Awesome. What were we watching? Is it what you were doing or how to begin or what?
That was like the simplest. It was just 3 LEDs, but they're doing the same thing. They're lighting up at a different sequence.
Awesome. Are you going to somehow share the link with us on the chats?
After video.
Yeah, I mean the link to the video for people who want to watch it and get into, starting with Arduino and stuff.
Okay, it's fine.
Awesome. It seems like Nosipho, like we said, she couldn't join us. Any last words to us who are watching? That's if, there's nobody who's got questions from the audience. I hope so. So any last words for us? What do we do from now on?
From now on, people can go and check out the Arduino projects. They can try out different Arduino projects, whatever project they want or like, and they could start with different components. Because each project has different components, and you can start working on it. And I'd like to thank everyone who came through and who came to support me. It really means a lot. Thank you for listening and participating and asking questions. Thank you, like a lot. Thank you.
Awesome stuff. I personally would like to also thank the Inspire Channel team, Microsoft Student Ambassadors who joined us, and those who support us. I know there are people on the call that are not ambassadors, but they're here to, listen. And also, thank you for Nosipho for trying to connect, even though, she had internet connections of which it was above her powers. Thank you very much for people who joined and myself as well. Thank you very much, Thembelishle, for also presenting to us. It was a lovely presentation and, thank you. I don't have anything else to say. Awesome. So I believe tomorrow it's Thursday. So tomorrow it's Power Thursday, where we have the Power Ninjas who will be, doing an introduction to Power Automate, if I'm not mistaken. So do subscribe to our YouTube channel, Inspire SA, and do follow us on, our social media, Inspire SA, on Twitter, Inspire SA, everywhere else. And I guess we'll just see you tomorrow on the YouTube channel. Reason why we're here, it's because one of the ambassadors, who is Thembelishle Meyiwa, was supposed to, create an event in order for her to advance to beta. But for tomorrow's show, it will be on Inspire SA channel on the YouTube channel. And also this recording as well will be on the Inspire SA channel. So yeah, man, if you would like to connect with Thembelishle, I guess you can, if I'm not mistaken, Thembelishle Meyiwa on social media. I guess you can say how we can reach out to her. Thembelishle, do you mind sharing with us how we can reach out to you?
Okay, so basically on all the platforms I use the same username. It's Lihle with LIHLERH_M on Instagram, Twitter, Facebook, and TikTok. If everyone, yeah, that's all.
Awesome. So thank you very much. I guess we'll get the code, guys. We'll get the code GitHub link on YouTube. Hopefully it will be under the description link. To the Inspire SA team, am I forgetting something, guys? Leto, I know you're here. Spelling, I know you're here.
Yeah. Sorry, my phone is lagging. You're not forgetting anything. I think you said everything, and we just want to make a huge thank you for the people who attended and listened to Lisa give her presentation, even though we had like a few problems. But thank you for sticking around, and thank you for being patient with us. That's it on my side. Bye.
Awesome, guys.
Yeah.
Yeah, Tori, you can speak.
I'm just amending what Letu said. Thank you very much, guys. We know that some of you are really busy. We could have done some other things with your time. Thank you for like taking 1 hour of your time and attending our session. I promise you, we're gonna keep having bigger and better sessions and keep improving every time. So thank you.
Awesome, awesome, Rock. I guess we can, start subscribing and be part of the notification gang on YouTube, so that you know when we upload the video and when we're live tomorrow at 6 p.m. South African Standard Time. Thank you.